Okay, welcome to another episode of XinaBox Daily. I'm gonna show how to program in Python on our CS11 and CC03 course today. I'm actually just gonna use the CS11 because whatever you can do on the CS11, you can do on CC03 exactly the same. The CS11 also have an SD card on the back, and I'm also gonna demonstrate that from the Python here today. So let's get cracking. How do we get it ready? So let me just quickly get you up to speed. I had a video about it last week, but just so you have it in one video, let me quickly show you. You go into GitHub and you go into our XinaBox repository, and I have pinned the MU editor up here at the top. And that's where I have put the different things. When we programmed the CW1 and CW2 last week, or actually mostly CW2, I promised to put some code in here, and there it is. I'm going to do the same as CS11 and CC03, so you will find the code here after I'm finished with today. Here you can download the MU editor. Here's the Apple version, Mac OS version, and a Windows 64-bit version. And if you need a 32-bit version, then let me know. I will compile one. But this is the two versions for almost most of the machines that's out there. And you can also program Python in another editor, but I'm going to use the MU editor because it works on all our cores and it works on microbit, and there's also it's standard software on the Raspberry Pi, so it's kind of like across all the different platforms we work with. For some of it you can use Visual Studio Code, and you can use other different IDEs. I might make a video on that later on. Now we want to get CS11 up and running in Python, so again, quick recap, you go to circuitpython.org, and here you go to downloads, and then you put in CS11 or XinaBox, whatever, you get this thing here, and you click, and you want to have download UF2. So the UF2 file is a one we can drag and drop. So you click on that, downloads pretty quickly because, you know, it's a little fellow, and I have it here in my download folder called Chrome. And then here says CircuitPython, so that's because I had CircuitPython installed already. So if you have something installed or it doesn't come up with CS11, which kind of like tells you in bootload mode, you double click on the reset button here, and it's kind of like ejects the CircuitPython, and now it says I have a CS11. And when you have the CS11, you simply just drag this into the CS11 folder, it programs it, it ejects the CS11, and now it says CircuitPython, and now you can see here some files. And there's actually a file already here from last time. So even though that I wrote this in, there's a piece of storage on the chip that hasn't been overwritten. You can't be sure of that, but in this case here, the file system here was intact. Now, on the back, I have a SD card. I'm not going to take it out and show you what I have on the SD card, but I just have a little text file that I put in there to play around with. So the way that, let me go into the MU editor first here. So I have the MU editor here, and if you are starting fresh like the screen is now, you click in serial, press enter, and you get the prompt. And here in the prompt you can then type a command like I had hanging from our last session, and you can see here I can calculate. So now you know that the CS11 is ready to work in CircuitPython with the MU editor. Now, unlike the CW1 and CW2, the code we had, or the MicroPython that is for CW1 and CW2 is generic MicroPython for the ESP32 and the ESP8266, you know, the CPUs or cores or whatever you want to MCUs that sits on the back of the CW1 and CW2. The CS11 here have a SAMD 21G18, you can see that's highlighted there, but the version of CircuitPython is specifically for our CS11. And because it's specifically for CS11, the different pins that we're using are very specific for this CS11, so we don't have to remember pins. For example, the RGB, the red, green, and blue LED on the CS11, the pins are called red, green, and blue. The I2C pins that we also had another, the SCL is called SCL and the SDA is called SDA, so it's straightforward. And then there's an extra pin here because we have to have a chip select that normally called CS, and on this one here it's called CS. So quite straightforward. What we have done is that in our CircuitPython version, because there's a SD card on the back, we have included Adafruit's SD card library in the build. So you don't have to actually include any extra library to use it just purely like it is here. Obviously, when you want to start using some of the xChips, then you have to have a library for that. But this episode here is just what's special about the CS11, so you can get going from the CS11 point of view. So I have prepared a little bit of code like I did last time here, and the big difference is that with the CW1 and CW2 I could do everything in a MU editor. There was like I could press run up here, and I could go to files and things like that. With the CS11, the way it works is that the serial allows me to communicate over the serial port here, but when I have to put files on it, I have to do it from my file system. So I can of course edit here, so I can go in and say new and take the code and I can save it, and then I can go into the file system and drag it over. But I can use any editor. So that's actually what I'm gonna just show here. So the Sublime text editor, it's free for personal use, I believe. Just get like a warning from time to time. I'm not sure, but you can go in and find Sublime text and figure that out. But I'm just going to demonstrate here because it have a nice color coding, and there's a lot of packages you can install. So if you're like me, who's programming Python in a lot of different environments, and therefore I like the same IDE, it's a little easier for me to use this IDE here. And you can install different packages. There's a YouTube video with Corey Schaefer who is talking about how to set up Sublime texts and using a lot of different things. And he's a much better skilled Python programmer than I am, so I suggest that you find his videos on YouTube. But I set mine up here, so let me quickly go through the code here. So from the top, we import a number of different libraries that I'm going to use. And I'm going to talk about the libraries in the individual section. I don't have, in the other one, I had like a section where I say special for CW1 and CW2. I don't have anything that's special here because this is actually just pure CircuitPython. I haven't referred to any specific pins, pin numbers, anything like that I have to remember. So I made a class here that's called my SD. So in the other I had like my network or something like that. And I have of course my I2C and my LEDs. So those are the same as last week. Let me quickly go through them, use a little bit more time on the SD. So I have this SD here, and this is actually more or less taken straight from example on the documentation side. So if I go here and say, where do we go? Oh, sorry. Let's go back here, CircuitPython. I think there's like a, no, I think it's called docs. Not CircuitPython, let me just see. No, it's not. So we say CircuitPython, and we say documentation here. Let's just try that. Here we go. CircuitPython read the docs.io. So there is the CircuitPython documentation. Okay. Now this one here also talks about a little bit of the differences there is from MicroPython and the history behind it and all that kind of stuff. So you can see here there's this differences from CircuitPython. So there's like the behavior, API, modules, and things like that. So there's a number of different things that's different from from CircuitPython. And I think what they try to do is that they have their speciality and they kind of like follow the MicroPython otherwise. I'm not going to go into that because you can actually read that yourself here. So, and now we, let's just see here, we can find I2C. Actually, let's do the SD card here. See if that's in there. It might not be because it's actually Adafruit here. They have done the library. So we say CircuitPython SD card. And we go down to this one here where we got into CircuitPython reads doc.io project SD. Okay. So here is actually a usage example. So this is exactly what I copied into my code. Okay, the only thing is that I put it inside a class. So you can see we define SPI, the CS with this chip select, the SD card, and then a file storage solution here. So if I go to this one, you can see this is I put that into an init function in my class. So when I instantiate my SD, that gets executed. And then I have a read SD, and that's actually the only one I use. An example that was the write SD, so I just put it in. I didn't actually test that it works, but this is the same as there was an example, so I assume it's all right. So what I'm going to do is I'm going to read a file that's in the root of the SD card. It's called test.txt. It's not in a folder called SD. SD is actually the fact that we're using an SD card. So in the storage system, the root folder in the storage system is SD, and that refers to the SD card, and then actually in the root of the SD card is this text.txt. Okay, it's not in a folder called SD. So, so I'm gonna read this test, and there's also where I can write like a hello world if I want to. Then I have my I2C library here, and there's the only difference is that I use bus.io I2C here. So that's a hardware bus. There's also in CircuitPython something called bitbang.io, where you can bitbang connecting to the I2C. And one of the things that's very nice in CircuitPython also, I haven't made an example of that here, is that you have a module where you have, and I'm not going to find it now, where you have a module where you can set up the CS11 as a slave, I2C slave. That means that, for example, you could have like, you can program, let's say, a data logger, and it works as a as a slave. And then you can connect that to, for example, the CW2. And then every time you have to store something in SD card, you just call the CS11 over I2C, and you send the data over there. So you can program the CS11 as a data logger in Python here because there's support for CS11 as a slave I2C. Okay, so this is almost the same. The only difference is that when you use this thing here, you have to lock I2C when you do something I2C, and then you have to unlock afterwards. Okay, I think it's different when you use the bitbang approach, then you just try, but when you use the hardware version of I2C, which of course is the right way, then you have to lock and unlock. You don't have to do that in MicroPython, but in CircuitPython you have to. And then we have the LED, and here in the LED, last time I had like one function that both defined what pin I was going to use, and you could set the direction, input output at the same time. In CircuitPython here, it's two different fields. So I'm taking R and say that's my red pin, and the direction is output because I want to, set it high, low for light. And I do the same for G and B, and then I plow that into a array. What I also had last time is I had a pattern where I had 0 for turn the light off and 1 for on. Here I just changed that to true and false because the way that the pins working here is that, and I have one here, it's called all off LEDs. I'm actually not using it, but if I was, I should actually go in and say equal false. So let me just get that right, but I'm not using the function, so therefore I didn't get the error. Anyhow, and one of the reasons I'm not using the function is because I'm not using this threading a timer module in this version here, because I'm not gonna do a lot of different things. So therefore I'm just flashing the LED while I was scanning the I2C. So here we have the I2C, similar to last one, an LED, and then I instantiate my SD, I just call it text. And then what I do is that I loop 10 times here where I do, I scan the xChip, and I toggle the LED, and then I sleep for 100 milliseconds. And then I read the SD card, and then what I do is that out here I'm actually just showing what the version it is of MicroPython. Now when I ran it last time, because each of the line ends with character return new line, when I read the file here, I actually want to not print my own character return new line. So I actually want to take this thing here and add that. So when I print the line here, it actually doesn't print an empty line afterwards. I'm just printing it as it is. So that's the code, and you can see I get like an error here. So sometimes I'm just going up to check what the error is, say invalid syntax, and I have that from time to time. I'll double check that looks right. I also have this anaconda function here where I can say just auto format and things like that, but it seems like no, it insists that I can't do this thing here. I'm gonna try it anyhow, and let's see how the code runs. So I'm gonna save it to CS11 here. So that's in my mu code folder, and I explained last time that there was a folder that when you use a CW1 and CW2, that's a folder where it looks, and I'm using the same folder here. So I'm just gonna save it into that folder, and if I look at the folder here, you can see I have the CS11 here. Sorry, that's not in that folder. I have it here in mu code, and then of course I have to then drag and drop it into CircuitPython here. So I do that, and then it's, I want to replace, of course, the old one. And now I have my code on the other side. I haven't any library and things like that. This is the only thing I have is this CS11. And if I then go into my mu editor here, I can then, if I have run it before, I have to restart it. I think I showed that in an earlier video. So because of that, I always do a soft reboot. And it says here, use Control-D to reload. What it does is actually, it also say here, it does a soft reboot here. So I do that. This means that, it's clean here. And the way I run it, I say import CS11. And you might be able to look and see the flashing here, but you know how it is with this thing here. I'm not so sure that you get the right color flashing, but you can see something is flashing there. And then here you can see what happened was that I have this file full of lorem ipsum, and it stops right here where I have my cursor. I don't know if you can see it's right there. And then I print out what version it is of Python and MicroPython. So Python is 3.4, this version here. So remember, I think the official out there is like 3.8 or something like that. So it's a few versions behind. And then MicroPython, and I'm not sure if this is a MicroPython or CircuitPython, but in my code, I'm using the value I get from sys implementation. I just put it together. I had the same sys implementation on old one. So that is what I'm using here. So there we have it. I had the LED flashing. I was scanning the I2C bus, and I had my 5 different addresses, because remember last time also I had the SiO2 here, which have 2 different sensors on it. The SL1 have 2 different sensors, and the SW1 have 1 sensor. So there's like 5 sensors, and therefore 5 I2C addresses. And then I read the SD card. I have this lorem ipsum file here that I read out from the SD card, and eventually I just printed out what version it is of Python here. So that file here I'm gonna upload to mu code so you can see how to use the different things. So if you want to kind of like get going with Python and you just want to make sure that your SD card works and it blinks and your I2C address and all that. And then the I2C, remember it's different here. I told about how in this one here you have to use lock and unlock. Okay, so because I2C is different here, when we do a library, we want the library to work both for MicroPython and CircuitPython, and for that matter, on a Raspberry Pi. So we have like instead of using I2C directly like here by using the bus.io and things like that, we have a core file. So we have a file called xcore, specifically for CS11 and CC03, and they're the same. And we have other xcore files for CW1 and CW2. So when we code and we say we want to write to I2C or use I2C, then via the core it will then convert it to here. So this is just a pure I2C in this method if you want to program your own stuff, but we are using another layer in between to make sure that our library doesn't have to write straight to I2C differently for each of the different core, but we have this little library we put in between, a module we call xcore that converted for us. That is it for me. I hope you are gonna have a little bit of fun programming Python, and I see you again later this week. Enjoy.